All right, hey. So this video is like a redo of the of the one I didn't take on class time since I couldn't record last time. So this is like a makeup kind of lesson video. But I'll still go through it all. You'll still get all your information. So that's that. Okay. So starting off, so today we're going over Java 4 lesson 3 and we're going over abstract classes. Right, so an abstract class is a class where you can't create an object for it, but you use it as a regular class to be used. So I'll explain a little bit more about what that means. But on to the next definition. An abstract method is a method that isn't initially created with any specific content within it, but would be overridden with information later on. So an example of an abstract class and method, you can see here. So first, it has the abstract keyword here, and then a class, and then a random. So this random, again, is just the name of it. Otherwise, it seems all the same. There's still the brackets. Notice here that this is what we call an abstract method. It looks exactly the same as a regular method, except it has a abstract keyword right before the return type. And it also doesn't have anything here, and it has a semicolon at the end of the parameter parentheses. Right. So what the purpose of an abstract class is the purpose is to create, you could do multiple things with. So for example, if you were doing something like, if you wanted an area perimeter abstract methods for shapes, for example. So then in that case, if you have regular classes that extend class, then all of the classes will have the implementation for it, and that makes it easier for when you're doing when you're programming, right? Since it's kind of all linked together, and that makes it easier to operate. Also, with abstract methods, if you have an abstract method and you have a regular class that extends the abstract class, you have to implement it in the abstract class. Like you have to override it in the regular class. Otherwise, you're going to get an error with your code because that's how abstract method is supposed to work for, right? If you don't implement it, you're going to get an error. So in a way, when you're implementing regular classes that extend an abstract class, it's kind of like a reminder for you to implement everything. So that's one purpose, but it also offers a common class from which you could create an array of the subclasses that extend the class. So this is also covered in a few more slides, but this in general is just saying that it provides a common point where you could do multiple things with it. So some notes on abstract classes. So an abstract class doesn't have to have a constructor unless you have variables that need setting, and it doesn't have to have abstract methods. So we mentioned that in the beginning that abstract classes, they're not used like regular classes sometimes, in the fact that you can't you can't create an object for it. So that's why you don't have to have a constructor. I mean, that's the same as a regular class, but in this case, if you have a constructor, you're not really calling on the abstract class. You're calling on it through the constructor of a subclass, or you're not directly calling the constructor. And yeah, so it doesn't have to have any abstract methods, just like how you don't have to have methods in regular classes. It can contain any number of abstract methods. You can't have abstract methods in regular classes. So that's probably another reason why you would use an abstract class, is mainly because you want to have abstract methods. An abstract class can have can have methods and variables that aren't abstract. So that means that you could just have regular methods and integer variables, string variables, that kind of thing. Every subclass of an abstract class either has to be abstract itself or has to override every one of the abstract class's methods. So yeah, if this subclass of an abstract class is abstract itself, then you don't have to implement anything in the abstract superclass, since it's only when like the subclass is a regular class that's when you have to override the abstract classes methods. So notes continued. So creating subclasses for abstract classes is the same as with regular classes. So what I mean by that is it's still the same. You do the abstract class random, for example, and then you do extends, whatever the name of it is, and that would work like usual. Abstract classes can extend abstract classes and works the same way as regular classes do, like I mentioned. Abstract classes don't have to override their abstract superclass, but if you have a regular class that extends that abstract class, then you have to override the abstract methods of both abstract classes, if any. So that means that if you have an abstract superclass and then an abstract subclass that extends that, and then you have your regular class that extends the abstract subclass, then that regular class, it has to implement all the abstract methods of both the abstract superclass and the abstract subclass. Otherwise, you're going to get an error. But so basically, regular classes just have to implement every single abstract method. So abstract classes can extend regular classes as well. So these are all just notes that specify specific details of abstract classes. Obviously, if I didn't give you any of these, you'd probably be able to figure out on your own anyways. But this is just to answer any questions you might have about it and prevent you from wasting time to having to experiment with this stuff. So I just provide it for you anyway. So example of how you might override an abstract method. So you can see here that if we're talking about the abstract method I gave in the example before, the display method, you can notice that when you're overriding it in a subclass, that the abstract keyword is gone. So it just looked like a regular method, and you can just see here that public void display, and then you do whatever you want here. So just notice that, okay, if I change, when I'm overriding it, I change this void here into an int, specifying that when I'm returning an integer, then you're also still going to get an error, because when you're changing this, you're basically creating a new method. Since if we didn't have the code I gave you before, you just assume that this was a new method. But so in this case, if you turn this into an int, it's like creating another method. And in that case, Java would still think that you didn't implement the abstract method. So when you're doing abstract methods, you have to do the exact same thing. So same return type, same parameters, same data type of parameters, and same name. Otherwise, you're going to get an error. Some extra information. So I mentioned that with abstract classes, it's easier for you to create subclasses with the same like superclass. So yeah, again, so with abstract classes, you can use them to create arrays. So the arrays would contain objects of their subclasses, if any, since if you remember, you can't create an object of an abstract class. So the main reason why you would use this is for their subclasses. So an example of initialization you can see here. So basically just like the same as always, just the type goes here. Yeah, it looks basically the same as always. And then in here, you just put objects of their subclasses, if there's any. And yeah, that's it for this lesson, sorry. It's not necessarily a hard lesson. It's sort of important for later classes. It's still good to know though. Also, for class problems, I didn't have time to create them on the day of the lesson, so I don't have any class problems for that day in specific. But what I let the students do was they create their own problems and then they solve them themselves. Just so that since you guys are the first lesson, so that means that you guys would probably be like TAs for future classes and that kind of thing. So I just wanted you guys to like practice with it and make sure that you guys are okay with it. So I don't have any specific ones, but for class problems, if you were to do some of these, I would like you to create your own problems and solve them. For the problems, there should be at least 4 of them. Let's say 2 of them should be comprehension questions, so like stuff that I went over in this slideshow. 1 of them should be a determine the output problem, and 1 of them should be a programming problem. And they should be a little bit challenging so that you can actually have to think about it to get it. Yeah, I think that's about it. Make sure you understand this lesson. Make sure you practice a bit and sure you understand. I know it was a bit of a weird week and I sent this out late, but if you have any questions, you can always ask me through email. So otherwise, that'd be it for this lesson.